of the day on page 29 in your packets. Solve word problems using systems of linear equations. So you're going to see this in the video. I would like you to try this question. I'm going to give you a couple hints. There are two numbers. Sasha has this riddle. There are two numbers. Well, let x equal the first, let y equal the second. The sum of the first number and twice the second, twice y, x plus twice y, is 14. The sum of the first number and twice the second is 14. That's an equation. That's one of the equations. Here's your let statements. Here's the first equation, EQ. When the second number is subtracted from, watch the order, the first, the result is 2. This is your second equation. So now you have two equations. What are the two numbers? So you can eliminate, substitute, graph, although there's not a piece of graph paper here, or guess with tables. I would eliminate. On to the next problem. Real-world problems, systems of linear equations. This is 5.3 in your 8th grade textbook. In fact, this is page 210 if you're interested. So you can follow along in the book if you want to. Solve real-world problems using systems of linear equations. You have learned to write single equations with two variables. You can use this skill to write two equations and two variables as the following example shows. At a carnival, there were 700 tickets sold for a total of $5,550. An adult ticket costs $10 and a child's ticket costs $5. Ooh, they set up this nice table. Find the number of adult tickets and the number of children's tickets sold. At a carnival, 700 tickets were sold. So that's one equation. And the value of them was $5,500 is the second equation. They also give you that a child's ticket is 5 and an adult's ticket is 10. So you can see in the table here that 10 times an adult ticket plus 5 times a child's ticket will give you the value equation. And we also know that adults plus children without value was 700 tickets. So we have two equations that we could solve. 10a plus 5c equals 5,500 and a plus c equals 700. So 10a's, you got a little space down here at the bottom, plus 5c's equals 5,500, and a plus c equals 700. So I'm going to multiply this by -5, and I can get my c's to cancel. So I get -5a's minus 5c's equals -3,500. When I combine these, I get 5a's equals 2,000. And dividing by 5, I get a equals 400. So we sold 400 adult tickets. So 400 plus c equals our 700. I'm using that equation. So obviously c is 300. And 400 times $10, that would be $4,000. I'm just checking in the first equation there. And 300 times 5 is $1,500. And yes, when you add that together, you get $5,500. So there's my check. They sold 400 adult tickets and 300 children's tickets. Solve using systems of linear equations. So I'm going to do these three problems. 2 bowls and 1 cup have a mass of 800 grams. Well, that's an equation. 2 bowls, mass of 2 bowls and 1 cup. A mass of 2 bowls and 1 cup. 2 bowls plus 1 cup equals 800 grams. So I'm using B and C for bowl and cup, right? And let the mass of B, bowl, and C for cup. Okay, so we got that. 1 bowl and 2 cups, so 1 bowl plus 2 cups is 700 grams. There's my 2 equations. I would multiply this second one by -2, why not? And get the B's to go away. So -2 B's, -4 C's, and -1400. So my B's cancel, and I get -3 C's equals -600. Well, dividing by -3 on both sides, I'm going to get that the cups must weigh 200 grams, right? So how much does a bowl weigh? Well, a bowl plus 2 cups, 2 times that 200, equals 700. So I'm plugging in, substituting in, that's 400. So a bowl must weigh 300, right? I substituted in, I can figure it out by subtracting 400. I can do that in my head, that's pretty easy. So yes, a bowl must weigh 300 grams and a cup must weigh 200 grams. Find the mass of a bowl and the mass of a cup. So let's check this. 2 times 300 is 600. So 600 plus the cup, which is 200, that does equal 800. So I want to check first, and now I can answer it. That it's 300 for the bowl and 200 for the cup. That's what the solution is. I'm going to answer it in a say bowl. Find the mass of a bowl. The bowl weighs, because I want to put the grams on that. Bowl weighs 300 grams and the cup 200 grams. G stands for grams. Okay, let's go to the next one. Elizabeth is thinking of a 2-digit number. So it has a tens and a ones place. When the tens digit is subtracted from the ones digit, the difference is 2. Well, that's an equation. 1/5 of the number, whole 2-digit thing, is 1 less than the sum of the digits. Oh, what is the number? Let the tens digit be C, I see, and the ones digit be D. Okay. And the tens digit, which is C, is subtracted from the ones digit, and the tens digit, which is the C, is subtracted from the ones digit, so D minus C, the answer is 2. Okay, well that's that one. When the tens digit is the C, is subtracted from, so that means minus C. The ones digit, which is the D, so D minus C equals 2. Okay, 1/5, oh boy, 1/5 of the number. Well, the number has a tens digit, which means it has 10 times that digit for the tens value, 10C, plus 1 times the ones place, which is just a D. So that's the digit. You have to multiply the C, the digit, times 10 in order to get it to be in a tens place value. 1/5 of the number is, well, that's the equal sign, 1 less than, so that's minus 1, the sum of the digits. Well, if I add the tens and the ones, that's the sum, it's 1 less than. Oof. So, I'm going to clear that 1/5. I'm going to multiply this entire thing by 5. I'm going to clear that. So then I just have 10c plus d equals, okay, I'm multiplying this 5 times c, 5c, and this d times 5, and that negative 1 times 5. Oh boy. So let's get everything together on one side. So let's combine like terms, move the smaller one. And I'm going to get 5c plus a d equals 5d's minus 5. Well, now if I subtract 5d's from both sides, get the d's together. So I'm going to put c and d on the same side. I get, because d minus c equals 2, so I want to have a constant by itself. So I want this negative 5 to be by itself. So I get 5c's minus 4d's, because d minus 5d is minus 4d's, equals negative 5. So that's my two equations. D minus c equals 2, and 5c minus 4d equals negative 5. Oof. 5c minus 4d equals negative 5. If I multiply this top equation times 5, so I'm going to use another color to make this stand out. So now I'm going to eliminate my c's by multiplying my original d minus c equals 2. So putting it in the same order here, it would be 5d, and 5 times negative c would be negative 5c. That's what I wanted to happen. I wanted my c's to go away. So that's a positive 5d equals 10. These cancel. 5d's take away 4d's is a d. 10 take away 5. Oh, d is 5. Well, that wasn't so bad. So if d is 5, 5 minus some c equals 2. So c is 3, obviously. So c is 3 and d is 5. So that c, 10 times c, the number is 35, right? 10 times c, so that's the tens digit. But to be the tens place, it would have to be 30, and the ones place. So the number is 35. So 1/5 of the number, 1/5 of 35 is 7. Is 1 less than the sum of the digits? Well, 5 plus 3 is 8. Take away 1, that is 7. So that makes sense. It does work in the 1/5 of the number is 1 less than the sum of the digits. What's the number? The number is 35. It works in both equations. So the number is 35. Well, that was an interesting problem. Ooh, not easy to figure that out with the tens and the ones. Cool problem. Cool, cool. Oh, love those. Christopher is thinking of two positive integers. Oh, here we go again. The sum of the integers is 27. Two positive integers. Okay, well, doesn't give me anything. This is kind of like the problem of the day. Let x equal the first. Let y equal the second. The sum of the integers is 27. Well, that's one equation. So x plus y equals 27. Well, that's easy. That's one equation. When twice the first is added to half the second, so twice the first is added to half the second, the sum is 24. Okay, that's my two equations, right? 2x plus half of y. Well, let's see. I could multiply this one by -2. Let's get the y's to cancel. Let's multiply by -2 on this one. So x plus y equals 27. That's remaining. -2 times 2x is -4x. -2 times a positive 1/2. Well, 2/2 makes a whole, which is going to give me a -1y, or just -y, equals -48. Oh, that's okay. because my variable is negative and my negative 48 and positive 27. 48 take away 27 is going to give you negative 21. Oops, negative 3x, not negative 4x there. Negative 4 plus a 1 gives you a negative 3x. Dividing by negative 3, careful there, x has to equal 7. Well, if x is 7, 7 plus what number y equals 27? Well, that's easy. Y has to equal 20. Okay, so 2 times 14, 2 times 7 is 14, plus half of y, so half of y, half of 20, has to equal, half of 20, I'm already doing it, half of 20 has to equal 24. Well, that's 14, and half of 20 is 10. Well, yeah, that is 24. So I'm checking it, works in both equations. Find the integers. The integers, getting a nice sable R, because this is word problems. The integers are 7 and 20. That's my solution, 7, 20. 7 and 20. So the fact that it says integers means that you can't come up with an answer like 3/4 or 6 5/10, because those are not integers. Whole signed value numbers, those are integers. So I know my answer is right, plus I checked it. So that's it for today.